Hi listeners, you are welcome to the continuation of our physics tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAM, WAEC, NECO and NAPTIP exam. Today will be the continuation of our elasticity. Specifically, we shall be discussing the calculation aspect of Hooke's law, majorly on the extension, tensile strain, tensile stress, and Young modulus. Before we proceed, I am Bangbade A. Now, before we continue, we need to consider the learning outcomes of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to calculate the extension of an elastic material of a given applied force. Listeners should also be able to calculate the natural length of an elastic material. They should be able to calculate the tensile stress and tensile strain of an elastic material. They should also be able to calculate the Young modulus of the elastic material. And lastly, they should be able to solve relevant UTME questions relating to the concepts of extension, tensile stress, tensile strain, and Young modulus. Now, we also need to revise the formulas learnt in video 14, that is on the elasticity. So I urge my listeners to please refer to our video 14 on elasticity for the necessary foundation for Hooke's law. But for this particular presentation, we shall try to revise the essential formulas that we will be making use of in this presentation. So according to video 14, we stated the mathematical expression for Hooke's law, which is F is directly proportional to E. Then when you introduce constant of proportionality, we have F equals KE, and you can make K the subject, and that will lead us to K equals F over E. Now, we also derive the formula connecting two forces and two extensions, and that is given as K equals F1 over E1 equals F2 over E2. So F1 here is the first force, F2 is the second force you are given. E1 is the extension got from as a result of F1, while E2 is the extension got as a result of F2. Also, we derive the formula for calculating the original length or natural length of an elastic material, and that is given to be L0 equals F1 L2 minus F2 L1 over F1 minus F2. Also in our video 14, we discuss the formula for tensile stress, which is a tensile force over cross-sectional area. Also, we made mention of the formula of tensile strain, which is the same thing as the extension over original length. Lastly, we talk about the Young modulus, which is tensile stress over tensile strain, or you have FL0 over AE. Now on to sample questions from the UTME. And the first question we shall be considering comes from 1987, number 14. And the question goes thus. a load of 5 Newton gives an extension of 0.56 centimeter in a wire which obeys Hooke's law. What is the extension caused by a load of 20 Newton? So you are given option A to be 1.12 centimeter, option B to be 2.14 centimeter, option C is 2.24 centimeter, and option D is 2.50 centimeter. Now the first thing is to write out the given parameters, and from the question we are given the first one, that is F1, which is 5 Newton. Then we are given the first extension, of course that will be our E1, which is 0.56 centimeter. Then you are now given the second extension, the second force to be 20 Newton, and they ask us to get E2. Now using the formula F1 over E1 equals F2 over E2, then when we substitute, that will give us F1, which is 5 Newton, divided by E1, which is 0.56 centimeter, then equals F2, that is 20 Newton, over E2 unknown. Then we can cross multiply. If we cross multiply, we get 5 Newton times E2 equals 20 Newton times 0.56 centimeter. Then divide both sides by 5 Newton. That will give us E2 equals 20 times 0.56 divided by 5 Newton. And that will lead us to E equals 4. Then you can use 5 to cut 20. That will be 5 here 1, 5 here 4. So eventually we have E equals 4 times 0.56 centimeter, and that is equivalent to E2 equals 2.24 centimeter, making option C the correct answer for this particular question. Now the next question we shall be considering comes from 1994, number 16, and the question goes thus: a force of 15 Newton stretches a spring to a total length of 30 centimeter. An additional force of 10 Newton stretches the spring 5 centimeter further. Calculate the original length of the string. So you are given option A to be 25.0 centimeter, option B to be 22.5 centimeter, option C to be 20.0 centimeter, option D to be 150 centimeter. Now on to solution. The first thing is to write out the given parameter as usual, and from the question we are given the first force, that is F1 equals 15 Newton. Then L1, that is the new length 1, is given to be 30 centimeter. Then we are given the second force F2 to be 10 Newton, while the extension got from it is 5 centimeter. Now how do we go about this? You have to use F1 over E1 equals F2 over E2. But you recollect that our E1 will be L1 minus L0. So in substituting for the formula, now you have F1 over L1 minus L0 equals F2 over E2. Then when you substitute, our F1 is 15 divided by L1, that is 30 centimeter, minus L0, which is unknown, equals F2, that is 10 Newton divided by E2, which is 5 centimeter. Then we can cross multiply. If we cross multiply, that will give us 10 n into 30 minus L0 equals 15 times 5. So 10 times 30 will be 300. Will be 300. 10 times 30 will be 300. Then minus 10 times L0 will be 10 L0 equals 15 times 5, which will be 75. Then you can collect the like times to get 10 L0 equals 300 minus 75. Then that means 10 L0 is 225. Now include 225. 10 L0 equals 225. Then you can divide through by 10 to get L0 equals 22.5. making option B the correct answer for this particular question. Now the next question we shall be considering comes from 1998, number 13, and the question goes thus: the tendon in a man's leg is 0.01 meter long. If the force of 5 newtons stretches the tendon by 2.0 times 10⁻⁻5 meter, calculate the strain on the muscle. We are given option A to be 5 times 10⁻⁶, option B to be 5 times 10⁻², option C to be 2 times 10⁻⁻3, option D is 2 times 10⁻⁻7. Now into solution. From the question we are given the natural length L0 to be 0.01 meter, then you are given extension E to be 2.0 times 10⁻⁻5 meter, then you are given force equals 5 Newton. Now we're to recall that the formula for calculating stress equals what? Extension over original length, that is E over L0. So in substituting for this, E is 2.0 times 10⁻⁻5 meter, then divided by L0, which is 0.01 meter. Now 0.01 meter can be taken to standard form, and that will be 1 times 10⁻⁻2 meter. Now we have 2.0 times 10⁻⁻5 divided by 10⁻⁻2 meter. Then we can take 10⁻⁻2 upward to become plus, and that will give us 2.0 times 10⁻⁻5 plus 2, making 2.0 times 10⁻⁻3 bonus. So if you substitute for that, you have E equals 2.0 times 10⁻⁻5 divided by 10⁻⁻2 meter now, and you can take 10⁻⁻2 upward, it will become plus. So according to indices, and that will give us 2.0 times 10⁻⁻5 plus 2, and that will give us 2.0 times 10⁻⁻3, making option C the correct answer for this particular question. Now the next question we shall be considering comes from 2011, number 4, and the question goes thus: a copper wire was subjected to a tensile stress of 7.7 times 10⁻⁷ Newton per meter square. Calculate the tensile strain of the wire. Then you are given in bracket Young modulus equals 1.1 times 10⁻11 Newton per meter square. Then you are given option A to be 7.0 times 10⁻⁻4, option B to be 2.2 times 10⁻⁻4, option C to be 2.0 times 10⁻⁻6, and option D to be 7.0 times 10⁻⁻3. Now onto solution. The first thing is to write out the given parameters, and in doing so, you are given stress to be 7.7 times 10⁻⁻7 Newton per meter square. Then the strain is not given. We are also given Young modulus to be 1.1 times 10⁻11 Newton per meter square. So using the formula Young modulus Y equals stress over strain. Then when we substitute Y is now 1.1 times 10⁻11 Newton per meter square, which is equal to the stress, which is 7.7 times 10⁻7 Newton per meter square over strain. So the next is to cross multiply and make strain the subject, and if you do that, we are going to have strain equals 7.7 times 10⁻7 Newton per meter square divided by 1.1 times 10⁻11 Newton per meter square. So finally we'll have strain equals 1.1 in 7.7 will give us 7. So that will be 7.0 times 10 raised to power minus 10 raised to power 7 minus 11, and that will give us uh, 10 raised to power 4. So making our answer now to be 7.0 times 10 raised to power minus 4, making option A the correct answer for this particular question. Now on to practice question from the UTME. And the first question we're bringing here comes from 2004, number 35. And the question goes thus: if a force of 50 newtons stretches a wire from 20 meter to 20.01 meter, what is the amount of force required to stretch the same material from 20 meter to 20.5 meter? We have option A to be 100 newton, option B to be 50 newton, option C to be 250 newton, while option D is 200 newton. Now the hint here is that we should record that F1 over E1 equals F2 over E2, and that your extension E is equal to new length minus original length. The expected answer here is 250 newton, and that is option C. That is option C. Now our next video will be on the energy and work done on a stress wire with sample questions and solution from UTME. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be bringing you more interesting lectures on subjects relating to UTME. Thank you.